Hopefully you've had a chance to work those examples. Let's see how well we did. Does rules apply? Well, we have secant of x. Secant of x does have asymptotes. It has asymptotes wherever cosine is equal to 0. Cosine is equal to 0 at negative pi over 2, positive pi over 2, 3 pi over 2, and so on. So negative pi over 4 to positive pi over 4, secant is perfectly fine. And if you remember the shape of secant, it looks very much like a parabola. It's not a parabola, but it's kind of that shape. So it's a nice smooth curve. So no corners, cusps, vertical tangents, or discontinuity. Therefore, our function is continuous on the closed interval and differentiable on the open interval. I know some of you are thinking, do I really have to write that every single time for AP Calculus? Yes, you do. The next thing we want to check is f of A and f of B. Negative pi over 4, that is in the fourth quadrant. Secant is positive in the fourth quadrant. That's going to give us a value of square root of 2. Pi over 4 is in the first quadrant. It has the same reference angle, so it's going to have the same numeric value. Therefore, Rolle's does apply. We just have to find those values. Here we go, derivative. The derivative of secant of x is secant of x tangent of x. We'll set that equal to 0. We'll set each one of those equal to 0, each factor equal to 0. When I'm going to solve those, remember secant of x, cosecant of x, they never equal 0, so that is not going to give us any solutions. Tangent does equal 0, smack dab in between the asymptotes, which the asymptotes for tangent is also at the pi over 2's, so smack dab in the middle of negative pi over 2 and positive pi over 2. X equals 0. Is that C? All of this is your answer. Does it apply? Does it apply? All of this up here says yes. Since it does, this is that C value. Okay, let's look at an example of the mean value theorem. Does it apply? If so, find those values of C. We have to be continuous and differentiable. Well, I have a problem at 0, but good news is that's not where I'm looking in my interval. My interval is from 1/2 to 2, so all is free and clear. We can't just say yes, it applies. We have to show that it applies. F of x is continuous on the closed interval. Think about how good you'll be after we do so many of these. And differentiable on the open interval. So mean value does apply. That's what the yes means. You've got to show it so they know you know it. This is the show me state after all. Now that we know it does apply, we'll have to find our f of A and our f of B and our derivative. If we put 1/2 into the original equation, we get 3. If we plug 2 in, we get 3/2. When you go to find your derivative, could you please make it easy on yourself? Look at your original equation here. You've got x plus 1 divided by x. Instead of busting out a quotient rule, which you're more than capable of doing, look at this. Remember, when you can divide it on your own, do that. I end up with 1 plus 1 over x. Well, that makes it much easier to find my derivative because I know then that that is negative 1 over x squared. Now I can put the pieces together. I know that my derivative is going to somewhere equal that slope. Okay, and that is a 1/2, sorry. Okay, so 3/2 minus 3 divided by 2 minus 1/2. Well, that turns out to be -1 over x squared equals -1. So if you cross multiply, you're looking at where x squared is equal to 1. So our possibilities are at +1 and -1. Whoa, where did that 2 come from? Jeepers creepers. Okay, so +1 and -1, look up at your interval. -1 isn't in the interval, so we have to cut it out. So this is our only C value. The only place in this interval where the instantaneous rate of change is equal to the average rate of change. Please make sure you're discussing the continuity and the differentiability. AP Calculus is different than Calc 1 in the fact that we have to super explain everything. They want to make sure we know our stuff, and we are more than willing to show them. All right, so I hope you did okay on your 2 problems that you had to do. If not, please come in and ask some questions, and I will see you tomorrow in class.